So I am here once again, and today we've got an Audioline 341 which has come in from a farmer. His brother has one of these, which I did last year, and he so likes it that he's managed to get one on eBay. Also come with a dodgy bit of power lead. I'll get it's one of these rewirable plugs, so I'll get Mr. Chippy to do that. And what I think we'll do right now is we'll chop that off, and we'll put our crocodile clip lead in at that point. That's interesting. One's copper and one's aluminium. So we'll put that wire in the vertical filing cabinet. Obviously we need to put a fuse holder on this and have it safe. So I'm going to try it first, although theoretically I ought not to, because it needs those 4 capacitors changing, whether it needs it or not, if you understand that, because those 4 are troublesome. Before I started this policy, we ended up with a setback, and although it's not my fault in inverted commas, we are now changing them on site for what they're worth. So we'll get this connected up to test gear. I did do an Amstrad yesterday, but I wasn't able to complete it because some wally has managed to snap the screws off from the audio IC to its heatsink, and our nylon screw kit starts at 3mm and they are 2.5mm, so I've had to order some, so that'll be a forthcoming attraction. So what piece of second-hand paper is it? It's a hymn from last Sunday. I find it easier as an organist to I've got all the hymn books scanned into the computer. In fact, I've been doing it since the 1980s. I've got 50 complete hymn books, each with 1,000 items, scanned into the computer, and it's now fantastic because we can choose best versions. And anyway, this is one of last week's, and I print them off because they're flat on the music desk, whereas if you start using the hymn books, and we're often using the words from one and the music from another, if you're using the actual books, the problem is they can fall via the keyboards onto your knee and onto the pedals. So Welby Church, if you put anything of any weight on the music desk, it unfolds. So there you are. So I nearly put Welby Church there, but it's Audioline 341. Right, I'll couple up the test instrument to the extension speaker socket as well, and then we'll get a cyanide reading, which is there. Switch the power supply on. It's an unknown set, so we'll start at 9 volts, 300 milliamps. That's interesting because we've got nothing. Oh, we have. Right, we'll go to 12 volts and limit it. There we go. It was in PA mode, so we had no display. It's drawing 192 milliamps, which is fine. So just make sure RF gain's up, squelch there, mic gain there, power. I think it's in for 4 watts. We want it high on the tone. Right, here goes. Switch some gear on. I'm not only doing the organ, I'm doing the accounts as well. And I'm cleaning some records. Doing half an hour on each relieves the boredom. I do the accounts like 3 days in 1 year, you know, just do it. Really, you know, people who are office workers do that kind of thing all day. Well, I'm not, and it's just one of those things that I just have to do. Right, so as we are at the moment, we've got dirty contact in the mic and there's a screw missing. So I hate to say this, he's probably going to end up with a new mic. And somebody might be able to rebuild that one. I think he's going to end up with a new mic. Right, I'll switch picture in picture on. And if I squeeze this microphone correctly, we may actually get a reading. So we're on the 3 watt scale, so we should have full scale deflection. We do. So TX is actually 4.5 watts, so that's got to come down. Deviation, if this mic works enough for me to do this. Wallow, wallow, wallow. 1 2 1 2 1 2. Why aren't we getting anything? Perhaps this mic's even duffer than I thought. Wallow, wallow. No, look, I've got no transmitted audio. So I'll tell you what we'll do. We'll take that mic off it. That's got multiple issues. And I'll have to do them a new mic. We have a test mic here, which is Uniden. There's stiffer leads on these, so I always know which ones are which. Okay, so on a new mic, straight into transmit. Let's look at deviation now. Wallow, 1 2 1 2. Wallow, that's better. So we'll just listen to ourselves. I'm on channel 12. I should have noticed that. Testing 1 2. Yep, that's fine. Wallow, wallow. It's 3.2 kilohertz. That needs to come down as well. Yeah, you know what they do? These people with, you know, who fiddle with radios, and they go, can you hear me better? Can you hear me better? Fiddle, fiddle, twiddle, twiddle. And the mate goes, yeah, but the mate's on a Fidelity 1000, and so the louder it is, the better it sounds. And then anything with some half-decent filtering. I mean, we did that team bass, and the customer said the filtering on those is pretty sharp, and you know, well, everybody sounds off frequency. Well, they will do, because everybody is off frequency, especially those using illegal radios. So this is a problem. So it's all right having wonderful filters on sets, but who are you going to communicate with? Apart from people with also got decent sets and not illegal trash. So deviation, 4.5 watts. Frequency, let's have a look at that. Now it's not adjustable on these sets, and that's within spec. That might change as the test set warms up. It's only been on... Oh, no, it has. It's been on half an hour plus. Because I switched it on before I did half an hour of a count. So that's in spec. But apart from changing crystals, there's nothing you can do. It would have to be below 7.9... what would it have to be? Oh, it would have to be 7.90... to something before it would have to be sorted. Right, receive. Let's have a look at that. So we'll go over to the cyanide meter, so you know I'm not cheating. We'll put in 2779125 in the signal generator. There we go. And so we need to set 12. Oh, it's right between scales, it always is. So on scale, on the 1 microvolt scale, it's doing 1 microvolt. 1.2 microvolts for 12 dB cyanide. We should do better than that. And then on the next scale up, it's doing 1.1 microvolts. So you can see it is around there. That's not as good as it should be. I certainly need it to be like 0.85 or better. Right, I will open it up and I'll take both lids off because we've got to change those capacitors. I'll switch the smouldering back on, which is a bit like a soldering iron. Wrong screws. Someone given this the kiss of death and put self-tappers in. That's really frustrating because it's difficult to undo that, as in put proper screws in. I'm going to give it a go. I'll disconnect everything. This is well beyond the call of duty. I'll disconnect everything and we'll go in the organ workshop. Well, I will, you won't. And we'll give that a bit of metal bashing and then we'll re-thread it. I've got the threading tool handy here, but I need to just close that up by using well, an anvil and a hammer. So I need to know which two have been wrecked. I'm just hoping there's no more than those two. And it would be the ones near the mic socket which are difficult to get something on that side in the vise or on the anvil. Yeah, I've got a self-tapper there. So I'll tell you what I'm going to do. I'll mark that. So I know. I'll mark those two. So I know. So on this model you have to unsolder the speaker. (16 ohms notice). And the capacitors we're going to be changing right now, that are both 470 microfarads, that, and this is the most troublesome one in the radio. The display would go out if that fails. So I'll just do that, and I'll tell you what, we'll go and get some posh Nikon ones from next door, and I'll see you when I've hit it. So just quickly, I managed to drop one of the very one I really wanted to show you being tested, but with the 470, one of them starting to read high, which is indicative of failure. The other one reads spot on. The 220 is already showing as faulty. So there we go. Right, back with you, and done a bit more of the accounts, spent another half hour on it. Went through 1 month's bank statement. Right, so I'll just put that on so that we don't have any capacitive effect. So reconnect it, and we'll be using the realistic service manual. The realistic service manuals are excellent, and I'm glad I spent a lot of money buying them. So plug it back in. I'm not expecting any VCO problem with this. I mean, the set's working now, we've swapped the mic. But obviously it's time for an overhaul and a retune. So just looking at the minimum acceptable is 3.4 watts. It's already doing that. What is the sensitivity? It's 1, and it's doing, we could say 1.1, so it's out of spec. I'm sure we can get that back right. So we'll start with the VCO. There's no reason to, but we'll do it just for the video. And for completeness. My Aldi yellow multimeter has found its way back from the chapel to here, but it hasn't found its way to my bench. Oh yeah, it's on top of one of the printers. It's where you keep multimeters. So we'll carry on using the £12.99, or was it £16.99 little one instead. So test point 1, and we want channel 40. So we'll just change that to channel 40, and we start in TX mode, and it's L17. So the equivalent realistic models are 2000, whereas if it was a smaller audio line, it's the 2001. It's a different layout, same circuit. So this is the board, the PA039AA, and this is the board PA034AA. So we want test point 1, and test point 1 is the resistor 52, which is about there. I'll have to change my glasses. And we're looking for 3 volts, 3.5 volts. I've got a sneaking suspicion this is going to be a floating chassis, so we'll connect the negative lead to the power. We'll just check we've got power. There we go. So I'll just swap those glasses. Because all these have got paint on as insulation, except resistor 52, so that's how we know which one it is. So I'll put the mic in one hand. And we'll go into transmit as soon as I get that on there. So we want 3.5 volts plus or minus 0.1. Well, to me that's spot on. So now we move to 20, channel 20. And it's test point 3, and we're going to swap to the oscilloscope. So we'll get rid of that. And so, unless these are being fiddled with, the VCO isn't likely to be out. The rider to that is the Cybernet chassis used in the Amstrad. Can do what it likes and move around. I don't just mean the Amstrad, that type of chassis, the 002F. Put the oscilloscope on. We want test point 3 this time, which is resistor 6. And resistor 6, I'll just move these out of the way. It's the top of that resistor there. So put that onto negative, and we'll put that onto there. So in receive, we're going to adjust L18 for maximum. L18 is there. And there's maximum. You could do that with an electronic voltmeter, you could probably do it with an RF probe, or you could not bother doing it at all. It's a bit over the top. Now we go to the receiver. We're not going to align the receiver. That's a bizarre way to do it. My training is to always do the transmitter first. Because some things are common, aren't they, like the frequency. I know we don't adjust the frequency on these, but it's just good practice, I think. This is where you need 2 copies of the manual, because now I don't know which is the coil number. I'll be backwards and forwards now, I can see. So L15 and 16, 15, 16, 15, 16. And they actually want you to put the oscilloscope on another test point. So we will, just for the laugh. And test point 2 is another resistor with its paint shaved off, resistor 33. So we're going to transmit. Hey presto, we have a waveform. I mean, considering this is doing 4.5 watts, these don't really need adjusting. You can see the peak there, and you can see the peak there. Let's try putting the oscilloscope away again. The reason we use that, there's 2 oscilloscopes in front of me. One I'm looking at the detectors with, and the other I'm looking at transmitted audio. We use that one. That's a more sophisticated and higher spec oscilloscope anyway, but it's convenient to bring it out and put it there, because if I start twiddling with the knobs on the bench oscilloscopes, the way it's set up, I just don't need to adjust anything, everything's set right, so it's much quicker to have that one. On one of the other benches, which is diagnostics, we've got a more sophisticated Hitachi oscilloscope with on-screen displays and things. I think it's branded Gold Star. That's LG when they called themselves Gold Star. They never called themselves their full name in this country, in the UK, which is Lucky Gold Star, and for some reason they now call themselves LG, which does not stand for Life's Good, it stands for Lucky Gold Star. How bizarre. Right, I don't think, I think in this end of the world, having a brand name with Lucky in it, people would be joking about, oh, I'd be lucky to work, whereas luck in that end of the world is very, very important. So, resistor L14, we're going backwards and forwards with this. L14, if I even see it. Oh yes, we're going to there. 14, 13, 12, 10. See whether I can remember those 4 stages. So, key up, and now we're on the RF power meter, so yep, you're seeing that. And that's clearly maximum. We're now at 5 watts. That wouldn't do its long ever too much good. Like driving your car around at maximum speed all day. And then we're looking for, yeah, it's 10, which I think the final one is 10. Yeah. So we this one for maximum. That is maximum. The way that was twitching, I'm wondering if there's a dry joint underneath, so that's something I'll look into before we button this up. And then the next one is what sets your power, and we're going to be tuning down for 4 watts. It says 3.8 watts in the manual, but of course we'll be doing 4. I'm just interested, this isn't part of what the manual says, but I'm interested in what the balance is like. Because on the Cybernet chassis you balance it, you don't on this. It's about 3.98 on 4 channel 40. It's about 4.01 on channel 1, so it is pretty well balanced. There we go. So that's done that. We'll just melt that wax. And the other thing about it when it's on higher power than it's supposed to be is the spurious emissions may be all over the place. I'm not going to prove it or disprove it with the spectrum analyzer, but it is just a point. Legality aside. So low power. No, first of all they want you. No, they do. They want you to do low power next. So low power. We'll switch the test set to to the 3 watt scale. It's doing 500 milliwatts, which is actually in spec, but we will just adjust it because that's what we're here to do, and it's VR4. It's there. I find useful. It is so useful having low power, especially when you're in a convoy and you're all in the traffic lights together. It can be, it can become unreadable on a set with no RF gain and no low power. Whereas this, be a 2-knob set, like the model under this, and so useful. But there you go. That was part of MPT 1320, and that disappeared when the specs changed. So the next thing we want you to do is to set the meter. So we'll go back to high power, and we want the meter to read what? The black zone. Well, that was a bit lazy, wasn't it? VR3. Labelled RFM for RF meter. We actually want it in the centre of the red zone. So that's that done. Now we've got deviation to do. It's a little bit high, so we'll just pop that down. Just try it there. Wallow, wallow, 1, 2. God, just take it that fraction lower. It's going to be an attraction, probably bellowing into it. Wallow, wallow. It's more of a 2.3 there. So we've done that. We've done that. It's around 2.3. So that's already fixed. So now we'll go on to receive. So we'll go back a page in this service manual. I'll show you how good these service manuals. You've got the pin out for the devices, you've got troubleshooting hints, you've got the voltage charts, then we start on with the layouts for the 2 different variants, and then we go to the component lists. I even got wiring for when people have chopped it up. Now this is going to be relevant to the realistic models, but most of the time you can get yourself out of the quagmire. So, receive. I think he's on holiday for another. I didn't need to do this yet. I could have done other ones earlier, but they're in a strict sequence. And I've got 2 waiting for parts, so you know we're kind of jumping forwards. So channel 20, yes. Let's make sure we're on frequency. So on 27.79125. So here we go. So we'll look at the site. Oh, we'll do the detector first. What do they tell you to do? They don't tell you to do it first, but it's good practice too. So we want 100 microvolts, so an S9 equivalent signal, because it sounds absolutely dreadful. Well, I think it does. How about that one? There we go. Take the bench light off. And we want the detector. I think it's going to be that one there. We'll just verify that. They tell it's L19. Yes, it is. That's quite well out, wasn't it? So that definitely needed doing. I thought it sounded a bit awful. So we'll now go to the cyanide meter. One day I'll move the fidelity 1000 that camera's on. Or find the instruction book for how to set the camera memories. So I want... Actually, have we got deviation a bit high because I was doing a higher... Yeah. There we go. So I want 4 dB on the meter, so we're not saturating the receiver. And we start, they say we start with L6, we need to do the front end first. Let's see where we are. I think they're the wrong way round. We're not doing it that way round. Sometimes I don't know who writes these things. So far, no improvement that I can see. There's a bit more signal on for these. But not as much as that. Back to a small signal. Larger signal. What about that? Tell you what though, it's not good enough. It's actually worse. Make sure that RF gain's not moved. Nope. Well folks, something's not right with this. I'll pause the video. Right, so here comes the next 30-minute session on this radio. We're doing everything in 30-minute sessions today. 30 minutes on the organ, 30 minutes on doing the accounts, 30 minutes on two-way radio, 30 minutes on cleaning records. Relieves the boredom. So we've changed. I'll tell you what, that sounds better. May not be though. Might be illusion. So on the back of this piece of paper, we've got the parts I needed to order for the next stage of the organ from yesterday, which was leather buttons, pull down wires and springs. Turn it to one side. Capacitor 2, 4.7 microfarads, capacitor 18, 1 microfarad, and capacitor 42, which is 22 microfarads. One of them has disappeared, but I've got two of them here. So let's see what this makes of these. Yeah, that's knackered. I'll just run that again. No, it's knackered. Oh, wise choice, Mr. 21. Right, so I'm going to try and retune the receiver. No change there. Slight change there. I love twanging that. Let's go for a bigger signal on that one. I may have to use the second signal generator for that. It looks like I've changed the capacitors around, all the capacitors around there. That could be where the anomaly is. So just do the detector, because I did change the one on the detector. So just go back to the oscilloscope. Stay still, you swine. That's definitely a peak. Back to the sine nav meter. Just try once more with this. Just going to use a wrong tool just for now. It's just not having the desired effect. So what I'm going to do, we'll just look at the... We'll just put 455 signal in. We'll unplug the signal generator. Just turn the volume down so it doesn't annoy us all. I think we'll use that lead. This signal generator doesn't go below 24 megs, so doing 455 and 10.695, you're gonna. We'll just see whether this, without looking at the service manual, just look at this. Whether it's 10.695, whether it's 455. I'll tell you what, we'll just put that into there. I'm not looking for any calibrated. I just want a bit of a signal. And a bit of an earth as well. Don't know where Mr. Chippy's crocodile clipped these are. He's probably hidden them. That'll do. So let's put this on. It's at 10.695. Yes, it is. I'm going to use the RF gain to attenuate this. Just see whether I can. There's a change with this on. Oh yes. There's our definite peak. So go back to our signal, our proper signal generator now. You just don't know what's happened to these sets in the past. Proper signal generator is on this lead. Right, so we'll now read off what we've got on the signal generator. And it's exactly the same. So we're just not getting anywhere. Oh, hang on, have I got the RF gain back up? Not quite, but it was there and it's now there. So I'll just drop that again. Yeah, it's still exactly the same. So we're going to have to look at transistors which could be low gain. Because I can't see anything now in the path that would affect it. Well, transistor 1 is the one, you know, which is nearest the aerial. So 2SC 1923. So I think we're going to have to turn the power off and we'll just go through them one by one till we get the gain to what's acceptable. So you just don't know what's happened. Transistor 1, Don't think I've ever changed any transistors in one of these. There's transistor 2, and there's transistor 1 just there. So I've disconnected the power, and we'll whip that out when I can find it on this side. Anyway, I'll pause the video while we pop that out. Right, so armed with Towers International and the envelope with the new parts in, we'll look up to SC 1923. Sounds like a year I ought to remember. 1923. 2 years before my late mother was born. I think a year after my dad was born. So, 2SC 1923. Oh, you got different levels of gain. Oh. Right. So it should be 2SC 1923 O. So what have we got? 70 to 140 the gain. 70 to 140 the HFE. We'll never remember that. 70 to 140. Well, that's in the 70 to 140 category. It's 94, so that's fine. What we're going to do is we'll pull one from the envelope and see if we can find these. May not be the right version, so we'll just have a look. The one that's in is definitely an O version, and the new ones I've got are the Y version. They're higher gain, they're 100 to 200, the ones I've got. So let's test the one I've got. Now, it might not be a good thing, it might be a good thing. So it's 87, this one. Well, that's actually out of spec, isn't it? That's not good at all. Let's just try another one at random. Let's just try one till we kind of get 100. There's always going to be a difference from device to device. $91. Let's pick another one. When we built one of those silly little medium wave transistor radio kits, and we selected all the transistors so they're in the right gain order for the circuit. I think that was a bit beyond what you're supposed to do. 91. I'll tell you what, we'll put a 91 in. I've already forgotten what the gain was of the one we took out. Was it 70 something? Let's just check again. Probably give us a different reading anyway. $67. So theoretically, he says, that should work better. So pop that in. So having put that transistor in, it's absolutely no different whatsoever. So we're barking up the wrong tree there. Well, we've gained 0.1 or something like that. That's not good enough. So the next transistor in the circuit is a FET, and these are quite vulnerable to being affected by static and things like this. So I'll mishandle this all I want, and let's see what happens when we take a reading on this one. Seems a bit confused over that. Let's see whether we've got these in stock or whether we've got to start rummaging. So it's a 2SK198. 2SK198. Just make sure that I'm reading that right, because this was a scan of a photocopy. Yeah, L. 2SK198L. Now, so this is something I don't like to have to do, and I had to recover this off a scrap chassis. We can't get these anymore. We'll have got equivalents, but that would be not what we're trying to do this afternoon. We're trying to do a bit of show and tell as to how we get out of these def set situations. So this doesn't give us any. We've got a different instrument actually. I'll go and get that. This is less sophisticated. Let's get the posh one. So let's see if we get a different reading on this posher version. You can plug this into a computer and all that. Right, that's that, and that's that. So what we got? Some right information there. I'd have to look that up in the data book as to what it even conveyed. It's not my thing of expertise. Let's try this one. Right. Well, all I can say is they both work. So we'll put the recovered one in the radio. You're supposed to be very careful how you handle these things. They're susceptible to static. So if you've got your nylon tracksuit on and your nylon carpet, that hole isn't cleaned out properly. Right, now let's see what happens. Bang. Power back on, radio back on, microphone plugged in so we can actually hear what it's doing. just going to do a quick retune around there because of changing devices. And what was the spec? Oh! Because I forget that these aren't as sensitive as Cybernet says. I'm getting 1 microvolt for 12 decibel cyanide. In fact, it's 10 decibel cyanide. Well, we are... Let's just get ourselves to 10. So on that scale, it's 0.89. And on the other scale... it's 0.88. So we're in, that's fine. So I'm expecting the better spec of 12 and not the lower one of 10. So ideally it would be better, of course, if it was 0.5 microvolts, but changing those 2 transistors, you know, you've just got a little bit of gain slightly down on one, a little bit of gain slightly down on another, and you know, those capacitors not 100%, and that's now brought the setup to an acceptable amount. Now they're not DXing on these, they're using them in tractors. I wouldn't want to DX on any of these because they are not as sensitive as some sets, which is probably why they're better for bleeder. I'll tell you what I just didn't do. I didn't have that bottom on when I did that little tune. See what we're getting now. It hasn't changed. Just see whether we can just touch that front end again. Just drop the attenuator. 0.26. Actually 0.7 on the other scale. So there we go. That's fine. Fine and dandy. I'll clean it up underneath with isopropyl. So we've ended up changing capacitor. Where's my piece of paper which came off a cake wrapper? So we've changed capacitor 2, capacitor 18, capacitor 42. We changed the 2 470s anyway, the 220 and the 220. I mean, this scrap chassis, I just pinched that part off. It's had loads and loads of work round the audio. They probably even changed the audio IC. All this, like they're looking for dry joints. Now, I've bought this in the phase loop chips missing, which, are, as you know, are unobtainable. I could buy 100 at £16.50 each. But I don't think I'm in the position to buy 100 for £16.50 each. I'd have to make a profit on it, and by the time I've imported them from Brazil, they're not going to be £16.50 each either. And nobody's going to want to pay like 25 quid for them, so I won't bother. But when we look at this, none of these capacitors have been changed. The very things which are going to make that audio intermittent have never been changed. So they're barking up the wrong tree there. There you are. What a waste. Anyway, we've gathered some bits off it, haven't we? And we keep doing. So, right, we'll get back to the service manual. I've overshot my session, but we'll just get this, we'll draw this to a close. But then we'll do a little on the air. I haven't got Mr. Chippy today, so we'll do a little, put it on the air and go one down a Roger and not get a Roger. Like we normally do. So we want the signal meter to read S9 for 100 microvolts. It even says so in the manual on this occasion. I get comments. The meter's not reading right. Well, it's reading right on S9. It's the only one that you calibrate it to. So, VR1 is S for S9, which is there. At the moment, it's reading plus. I'll just make sure that RF gain's up it is. So it's really being generous at the moment. So we'll make it less generous. Now it's on 9. And we now need to check the squelch. So we will turn the signal generator down. That's 0.3 of a microvolt, by the way. You can hear it down to about 0.25. So we need to put the squelch to full, switch the signal generator till we get to 100 microvolts. So I'll just put the attenuators on the inset picture, if my glasses aren't in the way. So at the moment we're at 1 microvolt. I want this to come in at 100 microvolts. 3, 10, 30, 100. It hasn't come in. So we need to adjust the squelch until it does come in. If it ever does. That's strange, it didn't. Just check where we are, because it's not going to be set. It won't quite set how we want it to. So the best I can get is 120 microvolts. So it's not that far out, because what you don't want is a squelch that never ever opens. So it's just the way I set these. I mean, what do they tell you to do? They tell you to set it to 1000 microvolts. Well, we're setting it to 100. So the way I'm setting it is out of spec anyway for what they want you to have it. So let's see what they say on the actual specification in the front here, because I set them all the same. It's just experience. So when we look at tight, I want to look at tight squelch, not tight wallets. Yeah, so sensitivity is 2000 microvolts. So 100 and yeah, they want it tighter than I want it, so you know that's fine. No wonder I can't get it lower. Right. So what we want is to turn the squelch right down, to turn the signal generator right down, and park it at 0.3 of a microvolt switched off. Now advance the squelch control till we just hit the threshold. There we are. Switch the signal generator back on, and let's see when it comes in. Well, that's not good. 3 microvolts, it's deaf as a post. I'll just try that once again. I may have not been good at setting the threshold. Here we go. Oh, that's better. So it's coming in where? It's got a long hysteresis. It's coming in at 0.56, 0.52 of a microvolt, and disappearing off at 0.25. So you can get the sensitivity if you're careful how you set it. Let's be a bit more rough how we set it and try it once again. So I'll switch the signal generator to standby. It's quite a slow hysteresis, so my tendency was to turn a knob, and you actually got to turn it slowly. Let's try it there. .5 microvolts. So yeah, you've got to be careful. Good. Well, that's that done then, isn't it? So he can put it in his brand new combine harvester, and there's a cue for a song. I've written it on the back of How Sweet the Name of Jesus Sounds. I told you about the time I worked at Groves Organ Builders, and my wages were on the back of old calendars, my wage slip. So I think we've made a nice set out of that, and we've done a bit to try and help with the screws. Right, we'll solder this speaker back on. So just for now, we'll just put a few screws in. We won't put them all in. I'll turn it off because you just keep catching the knobs when you're doing this. Right, so we'll put it on the aerial, take it off the test equipment, turn the smouldering bat off, and we'll pass this across to Mr. Chippy when he's working on Monday, and we'll have him do us on the air test with me. So it's probably about 4 o'clock on a Saturday. Plug the aerial in. This is going to be a long video, isn't it, with all that fault paraphernalia. One Anna Roger. You'll be lucky. $19 a Roger. So I've got the meter there, and it's only calibrated correctly, of course, at S9. And what is that? Showing S3.5 of hash. Because on this meter, got 1, 3, 6, 7, 9. So it's calibrated to 9, and it's nearly halfway across with absolutely no signal. I wonder what happens if you unplug the aerial. Oh, it goes down to 0. Must be the radar, I can't even speak, radar at Cranwell. Right, well there we go. I'll leave it on, and we'll do an on-the-air test on Monday. So thanks for watching the Audioline 341, which now has a new mic and actually works.